24 grams of magnesium react with dilute hydrochloric acid. Calculate the volume of hydrogen gas evolved at s.t.p. Given the atomic mass of magnesium to be 24 and the molar volume of a gas at s.t.p to be equal to 22.4 dm³. Solution. Before anything, I'd like to remind you to subscribe so you don't miss out on videos like this. Now going back to the question, we have the reaction to be between magnesium and hydrochloric acid. So the first thing to do before writing out the formula, or before thinking of the formula to use, is to write out the chemical equation showing the reaction between the magnesium and hydrochloric acid. So that will be the first thing we'll be doing here. We'll be writing out the equation showing the reaction between magnesium and hydrochloric acid. And for that, we have magnesium reacting with hydrochloric acid, and that's HCl, to give magnesium chloride, that's MgCl2 plus hydrogen gas. Now we've written out the equation, but the equation is not balanced yet, so we'll be balancing the chemical equation. For magnesium, we have one atom present in the reactant side, and in the product side we have one atom present as well. Checking for hydrogen, we have one in the reactant side, while in the product side we have two atoms present. So to balance hydrogen, we'll be adding 2 to the reactant side, so we have 2 here. Now we have 2 atoms of hydrogen present on both sides, and this 2 is affecting all other elements present here, so definitely is affecting chlorine as well. So in the reactant side we have 2 atoms of chlorine present, and in the product side we have 2 atoms of chlorine present as well. Now we can say we have a balanced chemical equation. Mind you, for any calculations you'll be doing, at least ensure you have a balanced chemical equation so as to have an accurate answer. Now after the chemical equation, after ensuring that it's balanced, the next thing to do now is to write out the formula we'll be using. But in this case now, we'll be using what we call a stoichiometric relationship. Now we are being asked to calculate the volume of hydrogen gas, and we are given the mass of magnesium that reacted with hydrochloric acid. So the elements will be considering or comparing in our stoichiometric relationship will just be magnesium and hydrogen gas. So we'll just be dealing with magnesium and hydrogen gas alone. For the stoichiometric relationship, from the chemical equation, we can conclude that 1 mole of magnesium produced 1 mole of hydrogen gas. The number of mole is gotten from the coefficient of the atom or the compound present. So now here I have 1, but since 1 can be insignificant in equations like this, so it is not necessary we write 1, but we know we have 1 present here. Here also it is 1, here 1, and here 2. We have 1 mole of magnesium is producing 1 mole of hydrogen gas. So now what I'm doing here is I'm comparing the number of moles of the substance we are dealing with. So now if 1 mole of magnesium produces 1 mole of hydrogen gas, we are being asked to calculate the volume of hydrogen gas, and we do not know the number of moles of magnesium that reacted, but we are given the mass of magnesium and the atomic mass of magnesium. So to make the work easier, the next thing to do here is to calculate the number of moles of magnesium that reacted with hydrochloric acid. So now to calculate number of moles, we have our formula to be moles equals mass over molar mass. And substituting this, now we have the mass of magnesium from the question. We are given 24 grams. Yeah, that is 24 grams of magnesium reacted divided by, so for molar mass of magnesium now, Since magnesium is just standing as one, since we have just one atom of magnesium present in the substance now, we have the molar mass to just be same thing as the atomic mass. So now the atomic mass is given to be 24, and that will also be standing as the molar mass. I want to believe that is cleared. I will come again. Molar mass of magnesium. Now to calculate the molar mass of any compound is always the sum of the atomic mass of each element present. So now here we have just magnesium present alone. That means the molar mass of magnesium will virtually be equivalent to the atomic mass of magnesium, since it is also one atom that is present. That is 1 times 24, we have 24. Now here I have 24 grams. Unit of molar mass is always in grams per mole. Now calculating this, I have 1 mole. Now let's go back to the relationship we have here. If 1 mole of magnesium liberates 1 mole of hydrogen gas, then 1 mole of magnesium as well, since the number of moles are equal now. So from here now, we got the number of moles of magnesium that reacted to be 1 mole, and this could vary depending on the mass given. So if the mass given is about 48 grams, definitely the answer we'll be having here will be 2 moles. Now let's continue. So 1 mole of magnesium will as well liberate, since from the equation we have 1 mole of magnesium to liberate 1 mole of hydrogen gas. Definitely here now, since the number of moles that reacted is also 1 mole, definitely we'll be having 1 mole of hydrogen gas evolved. Here we are given the molar volume of a gas at s.t.p to be 22.4 dm cube. So how do we make use of this? Given the molar volume of gas to be 22.4 dm cube simply means that at s.t.p, 1 mole of gas contains 22.4 dm cube. Volume of 1 mole of a gas is 22.4 dm cube. Let's put it that way. Now the number of moles of hydrogen gas that was liberated or that was evolved is 1 mole, and we are being asked to calculate the volume. So definitely if 1 mole of gas at s.t.p is 22.4 dm cube, so this implies that 1 mole of hydrogen gas at s.t.p, let me have that in brackets, will also contain 22.4 dm cube, and this will serve as the final answer. We can say volume of hydrogen gas evolved equals 22.4 dm cube. I want to believe that the solution here is well understood, and if there's any comment or anything you would like to ask, you can drop that in the comment section below. That'll be all on this. Don't forget to subscribe and also click on the notification bell so as to be notified as soon as more videos are being released. Thank you.